you may remember me as that jerk that you used to have to deal with in Chairman Perry's Water Committee. For those that didn't know me before that, I promise I'm a great guy. Also have a few of our members in the room who might also tell you differently from that as well. Don't listen to any of those folks that already actually know me. But I appreciate all of you being here. Certainly appreciate the members that I've got here in the room. If you hear any heckling, it probably is coming from them. You're welcome to join in the heckling. I just ask that you become members first. That's all I need. So, as Leah said, a year ago, the state legislature passed Senate Bill 601, and it created the Texas Produced Water Consortium. Our goal, our pretty much our whole focus is on the idea of potential beneficial use of produced water outside of the oil and gas industry. There are plenty of reports and folks out there that have been trying to put hard numbers to how much produced water that we have here in the state, and I'll get into that here in a second, our methodology. But in small, it's a massive amount of water that we're potentially talking about here. And I think, not putting words in the legislature's mouth, but I think one of the ideas that the legislature, in creating this consortium, but also in everything that they've done for the last several years, is trying to identify new sources of water that are going to help us meet the need that we've got, the shortages that we're planning or facing here soon. I saw Chairwoman Pop out there earlier from the Water Development Board. I'm sure you all know this number, but I'm going to go ahead and throw it out there every chance I get. From their state water plan over 50 years, you all know we're facing a 7 million acre foot per year shortage. That's something that weighs heavily, hopefully on everybody's mind, certainly on mine, as we started tackling this issue of produced water, trying to figure out, can it be treated? Can we identify standards? Can we identify economics that would make this system of beneficial reuse work? So from Senate Bill 601, we were essentially asked to focus on a couple of things. I'm not going to be able to say it verbatim, but it boils down to how much treated produced water are we really talking, or how much produced water are we talking about? Is it possible, is there a technology that exists to achieve a quality of water that could be reused beneficially? And buried in that idea is basically, what is that standard, what is that quality of water that would need to be achieved for various beneficial uses? What are the economics of that system? How can we make it economical if we could prove that we could treat this water for beneficial use? And then finally, what are the policy or regulatory implications or changes that need to be made to meet that need, to create this system in the state? That's essentially how we went about this whole process over the last year. We, the Texas Produced Water Consortium, which is housed at Texas Tech University, but is made up of stakeholders across the entire spectrum of water, produced water issues. We've got environmental NGOs, we've got oil and gas industry, midstreams, commercial recyclers, agricultural folks, landowners, groundwater owners, you name it, we've got them there. The point is trying to bring all of these ideas, these voices, this collective knowledge together to see if this is possible and to start trying to find some solutions to that question. In tackling those directives from Senate Bill 601, we established several subcommittees, met virtually over the course of the last year, not for any real health reasons other than it's just geographically made sense. We've got folks all across the state, we've got folks in other states around the nation. It just made sense to kind of meet where everybody could possibly join us. We've also had one in-person conference here in the last month, and we'll continue to kind of have some more public-facing meetings of that group as well. So getting back to kind of those directives, I think the first and biggest question that we needed to ask and answer was, how much produced water are we really talking about? If we're gonna even move forward with the idea of treating, of defining a market, defining the economics, defining the standards, is it even worth our time? How much water do we have? Right now, there's no specific requirement to report produced water volumes other than an annual report to the Railroad Commission of Texas, which requires essentially a 24-hour well test to be done on oil and gas producing wells. And in that 24-hour period, operators report the amount of oil, gas, and water that comes up out of the well. There are also an annual reporting form for saltwater disposal wells. It's an annual form, but they're supposed to report essentially monthly summaries of their volumes that are disposed. So using those two methods, using those two pieces of information from the Railroad Commission of Texas, our faculty within the consortium at Texas Tech endeavored basically, first of all, to define how much oil are we producing so that we can then go from the amount of oil we've produced to find a water to oil ratio to define how much produced water we're looking at, how much we're talking about. One of the things that quickly becomes apparent when you start digging into this issue, produced water is mainly coming from the Permian Basin in the state of Texas. Relative to every other basin, it is by far the largest. I believe we're talking about a billion some odd barrels of oil a year, which then, as we'll get to, gives you about 3 billion barrels, 3+ billion barrels of produced water a year out of that basin alone. So we focused solely on the Permian Basin. The faculty dove into those numbers, dove into the historical numbers for oil production, and then started also trying to derive projected oil production numbers as well. They also utilized those annual well tests to find the amount of water that was coming up in those wells to define a water to oil ratio for those wells. And we created water to oil ratios for every county in the Permian, and then we did it for the Delaware Basin and the Midland Basin as a whole, part of the Permian Basin. What we basically found from all that gobbledygook that I just spit out there was a water to oil ratio in the Delaware of about 5 to 1, so 5 barrels of water to 1 barrel of oil coming up, and in the Midland Basin about 2.6 or 2.7 to 1. So using that information, we projected to try to come out with a 38-year horizon of the amount of water we anticipate seeing, which is about 14 million barrels a day over the next 38 years on average. It's quite a bit. I've had to do calculations back and forth to go from barrels to gallons to acre feet and back. I know you talk in gallons and acre feet, so don't worry, I'll transition here in a minute. 14 million barrels a day, and then like I said, on average, we think that's somewhere in the ballpark of about 3.8 billion barrels a year. What that is in acre feet is about 511,000 acre feet a year of produced water. We have to kind of further narrow that number down to what we call a technically recoverable volume. Obviously, high TDS is a characterization of Permian produced water. We're talking about, on average, 120,000 to 130,000 TDS. So we have to treat, among many other constituents, I know Dan Muller with EDF's in the back there, he wants to make sure that I at least say that. Every time we talk about salinity, we get reminded there's other constituents. But salinity is kind of is the elephant in the room when you start talking about this. What are we going to do with all that salt? Especially when we're talking about 3-4 billion barrels of water a year with 120,000 milligrams per liter of salts. So in endeavoring to have this discussion to figure out what we're doing, the technology that we looked at has any number of recovery rates, but if we were to recover all of the water that we treated, we think we'd essentially create a new salt flats in all of West Texas and collapse the global salt market. We have some members that disagree with that, but we're still trying to derive those economics, but it's a massive amount of salt. So what we decided was maybe the easiest solution from there was to treat this water at about a 50% recovery level. So we're going to recover 50% treated water and then have about a 50% concentrated brine, that's about 250,000 TDS, that can then either still go to disposal or can go off to possibly be reused in the industry. So take that 511,000 acre feet that I said earlier and cut that in half. That's essentially what's going to be our conservative low number of the amount of treated produced water that we could anticipate seeing every year over the next 38 years. It's about 256,000 acre feet. We tried to make sure we were keeping that in perspective as we were talking. Region F, which is what covers most of the Permian Basin, their average annual need shortage over the next 50 years is about 80,000 acre foot. So in terms of that kind of local impact, I think it can't be understated. It could potentially be very useful, very beneficial to them. I think if you throw in, was that Region E to the far west Texas, I believe it actually covers both of those regions as well. So first question being, how much water are we talking about? 256,000 acre feet to 500-ish 1,000 acre feet a year that we could potentially treat and recover. The next question then becomes, is there technology that exists that can treat it and achieve a certain standard? And part of that is, what's the standard going to be for each of these beneficial uses? The standards and quality discussion was maybe one of the most heated areas we had of our membership. We have members that believe that this is a new water source. This Permian Basin produced water has not been adequately characterized, has not been adequately studied and tested. And in doing so, we need to test, we need to analyze that water, we need to figure out what constituents are in it, and then we need to run risk assessments on that water to figure out what the impacts could be on treated water to health and to human health and the environment. We also have a different set of members on both ends of the spectrum here that believe we already have standards that exist for many of these beneficial uses. We have permits that already exist, and we have technologies that exist in other parts of the world that we think we can just plug them in and start running. So, pretty diverse spectrum of ideas there. What we have essentially found for the consortium, what we're going to detail in this report in a couple days, is that we do in fact need pilot projects to treat and provide treated produced water samples, specifically from the Permian Basin, so that we can actually start to run some characteristics analysis. We're going to have members pretty soon start talking about what those standards targets are going to be. Where do we set the bookends to say this is what you have to achieve? And then how do we then test after the fact to say what did you achieve and what's still in that water, and how do we move forward from there? Those pilot projects are maybe the most significant thing that we've got coming out in the report, as we're also going to be asking the legislature for funding to help us with the testing and analysis that is necessary off of that water. But back on the technology side, and again, I'm sure I'm not telling you anything you didn't already know, largely our technology review in the paper was based off of what we know about seawater desalination in many other places. With seawater desalination, 30,000 average TDS, we reviewed 5 different technologies: reverse osmosis, multi-effect distillation, and a couple of other acronyms I'm not going to remember right now because I'm not an engineer, to basically say, here's what technology exists, here's maybe our best bet, our best shot at technology that could treat this water and possibly provide some answers to us as well. From there, we move on to the economics piece. So what are the economics of this produced water system? What we know right now today, the economics don't work. Disposal is by far the cheapest option that folks have in managing their produced water issues. We found on average disposal costs range from about 60 to 70 cents a barrel. Put in context through discussion with our consortium members, folks that have tried some treatment options before, I think we decided there was about an average cost of treatment currently at about $2.55 a barrel, can go up as high as $10 a barrel in some instances. So we have quite a gap there, quite a gap we need to bridge and figure out how we're going to make it more economical. So we started trying to essentially define what are the economics that could exist in the system. What are the treatment costs? What are the disposal costs? And then what are some of those exterior costs that are going to play into this potential produced water market? So what does it look like for water in the Permian Basin currently? What are the costs that people are paying for groundwater? What are the costs that people are paying for the water for their agricultural consumption? We were trying to basically derive several different inputs that are going to continue to go into building an economic model that we hope is going to be very crucial in this process someday. What we found, obviously some pretty grim outlay. The groundwater, the costs for groundwater, again, I'm talking to the group that probably knows well more than I do, but what we found on a basis of just an agricultural user, a groundwater owner for agricultural irrigation, about 3 cents a barrel. And that's really just the cost for them to run the energy to pump their water and possibly move their pivot system. about 3 cents a barrel. Again, remembering 60 cents for disposal, possibly $2.55 for treated water. So the agricultural, the groundwater costs are pretty low. We also did dug into the Region F water plan, looked at those water supply projects that were listed in there to try to find what does it look like for the costs of those projects after debt service. So what is the cost of that groundwater after debt service? Again, what we found over about 40 projects was an average cost per barrel of about 7 cents a barrel. So still not quite going to get us there. Going outside those bounds as well, even from that, from those Region F water supply projects, as well as some input that we had from some municipal utilities in Region F. We tried to find what does a municipal system charge for their water and what do they have to pay for their water. Municipal system, on average, what we saw in Region F was about 20 cents for them to treat their water, and then on average about 40 cents a barrel that they charge to their consumers for that water. So we could say, what's the potential value of water to consumers in this region? About 40 cents. So we're getting closer. We're getting closer on bridging that gap, but it's still not quite there. It's close, but it's a little ways off. There's also quite a bit of discussion about water markets over the course of it. I mean, it's hard not to talk about a new water source in an arid region and how you're going to move it to multiple different users without discussing a water market. But that's an area that we're going to have to basically keep studying and digging into over the next year or so. Lastly, basically from there, policy initiatives that we're looking at. So as I mentioned before, we have some diversity of thought in the standards approach. We do not have recommended guidance on standards permitting and testing at this point in time. That will basically come from the pilot projects that we're going to work to set up here in the next couple months and hope to run basically over the next year or two. We are asking essentially for state agencies to just give some thought to how they're going to work together in this scenario. Right now, it seems pretty clear to us that the Railroad Commission of Texas has primacy over produced water in every area other than direct discharge into surface waters of the state. And that goes to TCEQ. But there are some unique situations that could arise if you start beneficially using outside the oil and gas industry. Treated produced water that's permitted through the Railroad Commission goes to a manufacturing facility that has TCEQ permits. There's questions. So we've kind of given a nod to say state agencies need to start thinking about this. As I mentioned before, we're looking at funding for the pilot projects from the state legislature to help us fund the testing and analysis that will basically then continue funding or continue informing the system of standards and informing the economics as well. Outside of that, I think that's all I've got. We do have, as Leah mentioned, the report is going to be out on Thursday. We're working to try to get it published to our website, but if it doesn't happen there, we'll make sure that it's available in some other format. And with that, I think I'll just take questions.
So I did get one or two that came in on the app. Speaking of which, if you want to submit a question on the app, you can do that. There's an icon with a question mark. But first, see if anyone in the audience wants to approach one of the mics. Okay. So the first question that came in, you touched on a bit at the end, but I'll just maybe have you reiterate it. What are the regulatory changes that you're recommending at this point?
Sure. None at the moment. Like I said, we don't have, the consortium collectively does not have guidance, any new suggested guidance for regulatory changes at the moment. Like we've said, really the focus is, the Railroad Commission of Texas already has a land application permit that exists that they are using. My understanding is right now it's really only been permitted over one formation, I believe that's in this area. That's, I think they said it's pretty much pumping out fresh water. It's pretty quality water that's already coming out. So they already have a land application permit. They don't have permits that specifically go to beneficial use yet. We've obviously talked with them at length about what it looks like, what happens. They don't have that pathway at the moment, but they have broad, discretion to start identifying those pathways and figuring out those permits. So no changes at this time.
And then the other question I think probably goes to the economics component you talked about. The question was about transport and all this water being in the Permian Basin and was part of the evaluation figuring out how much it would cost and what are, I think, landowner kind of type issues in trying to move that water to where it's needed?
Good, great question. That's certainly an input that's going to come into play in the economics. I think we determined on average, as far as a cost to move, some of the literature we dove into, I believe, highlighted maybe a 30 to 40 cent pipeline movement cost, and that's really coming from the midstreams. That's how much it costs for them to move that produced water currently. That's going to be a big question. I left this out. I apologize. One of the other things that was detailed in the report, not a strict directive to do this, but basically a call to the regional planning groups to say, start thinking about the potential of produced water as you move forward. If we are going to need to build pipelines, if we're able to prove that the water can be treated, that it's safe to use for beneficial use, we're going to need pipelines to move it. And in order to do that, SWIFT is obviously the shining light of funding programs that everybody looks to. So we basically said, regional planning groups, stay apprised of what we're doing, keep in tune with what we're talking about, because this could potentially be a source for you in the future that you might want to look at for your regional planning. Outside of that, the only other good method of transportation would be through riverbeds and streams, and that's not something that we were able to kind of tackle in this report this go around.
Okay, and then another one just came in. I think what are options for bringing the cost down? And I think that's probably in reference to the treatment costs that you mentioned.
Sure. I can't stand here today and tell you exactly what could help bring the cost down of treatment. I'm not an engineer. We know that technological efficiencies occur all the time. There are several companies that are out there right now, some in Texas and some around the nation, that are treating this water and doing it effectively. But there's still, that number is still very high. I can't tell you technologically how we bring that cost down. I think what we think would be more important to highlight in the economic system is what are those other inputs that are going to not bring the cost down, but are going to serve as revenue that's going to offset those costs. And that's the value of that water to end users that we could possibly get to. There are external factors like future value of this water in scarcity conditions that we're facing. What's that water going to look like in 20 years if it doesn't exist? There are, environmental implications that are going on, regulatory implications. As new regulations are stacked on the industry, it drives the cost of certain things up, like disposal. So some of those other factors are going to start pushing the money in the opposite direction. Technology will get more efficient, it will come down, but I can't tell you specifically how fast that would be or what's going to make that happen. I think it's really, I make this statement, make sure I make this statement very carefully. There are no facilities in the Permian Basin currently that are treating water to a quality beyond that which is necessary for reuse in the oil and gas industry. That's about as politically correct as I think I can make that statement. They're treating basically to a clean brine standard. There are no facilities that are pushing beyond that to a higher quality. So it's going to take some time. It's going to take some proof of the system. It's going to take some technology companies coming in, learning, failing, getting back up for us to find what those economics are, to drive those efficiencies.
And another one just came in. Did the consortium discuss undisclosed chemicals and how to address testing for those?
Yeah, that's, I don't know who sent that in, but it feels like a question I have from members constantly. Yeah, that's a great question. There are, again, going back to that discussion of kind of two schools of thought between the membership there are certainly those members who are pointing out, look, there are chemicals, there's constituents in here that we don't know. And they want to know as much as they possibly can about that water as fast as they can. The New Mexico Consortium, I'm ashamed I haven't mentioned it until now, I apologize, but New Mexico has a consortium that started a couple years ago. They've actually done quite a bit of work in this area. They've tried to identify constituents. They've done mass chromatography, all kinds of very in-depth testing, and they're also developing their own risk assessment framework as well. So they're trying to identify, I think, what they call the unknown unknowns. What's in the water, but what's in the water that we don't know. So yes, we had that discussion. Right now we don't have an approach to it set. Like I said, that's an area that we're going to start talking about for these pilot projects. How are we going to move forward in identifying what we need to identify and finding a system that's going to tell us what we need to know?
And I'll just, question of mine, and I think what'll maybe bring this all together, the future of the consortium. You mentioned these pilot projects. Does the consortium need something more to continue to exist and move forward with these next steps in terms of the upcoming legislative session?
Funding, right? That's the name of the game. We can use all the funding we need. We're trying to drive a system of pilot projects that is economical of our own accord and doesn't get outside the bounds or go back to the legislature to continue asking for funding, because it's an unsure zone. I say don't ever count on money to come from the state. But in doing that, we're going to look for the pilot project process is going to basically break down, I think, into two categories. We're going to have a location-based RFP and then a technology-based RFP. Location-based, we're going to be asking for facilities that exist that already bring in produced water that can give us access to that water to plug in a technology system, treat it, and then put that right back into the system to go right back where all the rest of the produced water is going to go for disposal or reuse. So our hope is that a large part of that cost is going to be borne by volunteers of midstream or operators that are vested in the system. They're looking for solutions, and they want to be partners in finding those solutions. Same thing with technology providers that are going to come forward. We hope we're going to lean on them quite a bit to say, if you want to prove up your technology, it's going to take a little bit of from you and a little bit from us. So funding.